All right. Hello, CIS C157 students. I wanted to record another video tutorial for the Module 13 assignment that you'll all be working on. So in the last module, we started working with classes and object-oriented programming. And in my video tutorial, we built a single car class. So we had one blueprint and we created several car objects from that blueprint. In this module, we're going to go a little bit further. So we're still going to stick with the car theme here, but we're going to model it a little bit differently. So in real like fleets, for example, you won't always have the same type of vehicle. So you might have something like a sports car, some trucks, and maybe electric vehicles. Each kind of these share a lot in common, but each kind also have their own special purpose. And that's what inheritance is used for in object-oriented programming. So we're going to build a parent class called vehicle today, and then we're going to build several child classes that inherit from it. We're also going to see how to define custom exceptions and how to check class relationships, and then also how to handle errors with try and except, which we've been using for a while here in this course. So we're not going to build the your assignment program directly. Instead, we're going to work with vehicles here, but you should be able to take some of the design and concepts that we cover and apply them to your individual assignment, which is sticking with the LLM theme. All right, so we're going to start off here in Visual Studio Code, and I already have a Python file created called vehicle demo. So in this program, the parent class, again, is going to represent any vehicle in all the cars that we have access to. And then the child classes will be the specific types of vehicle. So each vehicle will have a list of features that it supports, like, for example, sports mode, or towing or fast charging for the electric vehicle. And if someone tries to use a feature for a vehicle that does not support it, the program is going to raise one of our custom exceptions here. So the first thing I'm going to do, even before writing the parent class, is I'm going to define a custom exception. And a custom exception is just a class that inherits from Python's built-in exception class. So it lets us create error types that are specific to our program. So I will name mine unsupported feature error. So let me write that here. All right, and that is the entire unsupported feature error class. So this is the entire definition. Notice that we use the pass keyword in the body of the class, and the pass keyword means that the class has no extra code. It still inherits everything from the default exception, though, as we can see passed in here. So it works like any other exception. So the main reason that we want a custom exception is so the program can tell the difference between a feature problem that we have or any other kind of error that might exist in code. Later, when we introduce the try and except block, we will catch this specific error by name. So it'll become a little bit more clear on why we want to use it. Okay, now that we have that custom exception defined here, we're going to just move on and define our parent class for this program. So again, our parent class here is a vehicle. It's similar to the car class from the video tutorial I went over last week, but we're going to add a few more methods here. So let me go ahead and write up the code for this vehicle class, and then we'll walk through it together. So I'll have a make and model just like last time in our default constructor. And like last time, we're going to assign these instance variables. So self.make equals make, self.model equals model, and then self.vehicle type equals vehicle. And we'll get to this one here. And then we're going to update the vehicle count whenever a new vehicle is created. So just like last time. All right, and that should be everything for our constructor. Let's define some more methods now for this class. The first one we're going to do is the dunder stir method, which will only accept self And this one is a dunder method or a built-in method for classes in Python that governs what prints if you try to print an object from this class. So for us, we're going to just return an F string here. And that looks good. Now we'll define some actual methods, custom methods here on this class. My first one will be called start engine, and it will accept self. And this is just going to print something for now. So we'll print this engine started here. All right. I'm going to define another method called get features, which will again just accept self. And then we are going to return features that exist for all different types of vehicles. So for us, I'm going to return a list that has drive and brake. Just those two features, which will again exist on all of the child classes when we get there. And let's see, what do we want? And then we'll do one more called use feature. And this one is going to accept self and a feature name. And then we'll say if the feature name is in self.getFeatures. So we're going to call the method we just defined. So we're checking whether or not the feature name that's passed in exists in the available features. Then we're going to just return an F string again. Else, if it's not in the list, this is where we're going to call our unsupported feature. So we will raise unsupported feature error, and we will pass into it an F string for the specific error message. Okay, so I'm just passing in this descriptive message, basically saying this make and model does not support whatever feature raised this error. All right, and that's it for now for our parent class. So let's walk through this again. So vehicle count at the top, this is a class level variable that we have. And again, just like before, we're tracking how many vehicles we've created later in our program. Same idea as total cars from the last tutorial. The constructor we talked about, it stores the make and the model as instance variables, and then it sets a default vehicle type. That is what this equals here represents. We're setting just the default type to vehicle for right now. The dunder stir method returns a readable summary. So like this could return Toyota Corolla and then in parentheses vehicle. Start engine, right? We're just printing a message. Think of this as the parent's version of a startup behavior. Get feature returns the default list of features every vehicle supports. So this is the base list, and driving and braking are the only one in my example that every vehicle type can perform. And then we have use feature. So this is the important one here. It checks whether the requested feature is in the list returned by get feature that we're calling right here. If it is, it returns basically a success message that we've written. And if not, we are raising and utilizing our unsupported feature error that we defined above. And we're just passing in the message that we want displayed as an error message. All right, and that is it for our parent class here, our vehicle class. So now that we have our parent, we need to define some child classes. And I'm going to define 3 separate child classes, each one inheriting from vehicle and specifically overriding the get features method that we have here. So this is the method that we're going to be overriding in each one of our child classes. So let me go through and define all of these. They'll all look very similar, and then we'll talk through it. So I'm going to define a sports car. And again, it will inherit from our parent vehicle class. I'm going to define our method there. And you can see, at least in my IDE, it completed a lot of what we needed to do. So I'm going to undo that just so I can write it out. So the first thing is we'll define our default constructor, and it will take self, make, and model, just like the parent class. And then we are going to call the parent class's constructor using this super init method here with a make and model. And then we are going to change the vehicle type that we declared in our parent class. So this vehicle type is going to equal sports car. All right. And then I'm just going to define again the get features method because that's the one that we're changing or overriding. All right, and instead of doing what it typed out for me, the returning default, we're going to return a new list here. And it's going to include drive and brake from the parent, but we're also going to add sport mode and let's do like launch control. All right, just some arbitrary features that this sports car might have. And that's it. That is it for one of the child classes. We're going to repeat this process for a couple of different types of vehicles. So I'm going to define a truck. Same thing. These will all look very similar, as they will in your LLM example as well. So we kind of call this some boilerplate code here. Okay, and so for this get features for a truck, same, we'll do drive and brake from the parent class, and then we will add like a tow feature and maybe a four-wheel drive that a truck might have. All right, and my last child class will be an electric vehicle. Call it an electric car, just so it doesn't have vehicle in it. The default constructor, as always, will have self, make, and model. And then we'll call the parents constructor. And then we will set the vehicle type. And we'll define the get features method. And we will return yet again another list here with drive, brake, and then for an electric car, let's say fast charge and regenerative. Let's just do regen braking. All right, those are some features on electric cars. Okay, let's review this again. So notice the pattern for each child class. We always start off with our default constructor, and the first thing we do in our default constructor is call the parent class's constructor. And then we make any changes we want to any other instance variables. For each of these child classes, we are just redefining the default vehicle type, which again, in our parent is just vehicle. We're redefining that to the specific type of vehicle that we have here in a child class. So sports car or truck or electric car. Then we are picking kind of our one method that we're going to override for each one of these. For us, it's get features. And we're simply updating what this method does. As a reminder, in our parent class, this method just returns the drive and brake features. For each child class, it will include drive and brake because we don't want to lose those, but it will also add additional features based on the type of vehicle that it is. Let me see if there's anything else I want to go over. I don't think so. That pretty much covers everything with a child class. Kind of a key takeaway. This super init is really important because it pulls in basically these two pieces right here. Right, it actually pulls in everything, the vehicle count and the self.vehicle type. Everything that happens in the parent's constructor is basically copied over for this child class, and then it's up to us to redefine anything we want to, like this self.vehicle type, for example, and then make any modifications or overrides. Okay, so now that we have our parent class and all of our child classes, we've kind of done the heavy lifting for defining all of the classes. Now we can get into the main part of our program where we are creating objects and, calling some of these methods here. So let me create one object from each class, and then demonstrate the methods on those objects. So this would be like the main part of your LLM prompt program. So for here, I'm just going to do a print statement to kind of start with a title. So we'll say vehicle fleet, right? Just so we have a header here. And then just like we did last week, I'm going to define three cars basically. So car one equals, now I'm going to call the child classes directly. So let's start with the sports car. And we'll say that this is a Chevrolet. How about Corvette for a sports car? Then we'll do car two equals, we'll make a truck. Whoops, truck. And this will be a Ford, and we'll do like an F-150. And then car three, we'll do the electric car, and we'll do a Tesla. We'll do a Model 3. All right, so we create our individual car objects there, and then I'm going to do a loop to go through them and demonstrate kind of some of the things we defined above in our classes. So for vehicle in a list with car one, car two, and car three. So for each of the cars we made, what do we want to do? Let's print the car. We're going to call the print method to demonstrate what our dunder stir method does. Then we are going to start the engine for all of them. So we'll do vehicle and we'll call our start engine. Make sure, yep, we have that right there. So we're calling that. And then we will print the features that are available. So we'll say features, and then we will just call vehicle.get features, which again is a parent class method that we have here. Or sorry, it's an individual overridden method that we have in each of our classes. And then we'll just do another print at the end here. Okay. So again, we're creating one object for each class. We're looping through. For each variable, we are printing what the object looks like based on our dunder stir method. Then we start the engine, which we inherit from the parent class. And then we print the features, which are overridden for each one of these child cars here. So even though we never wrote a stir method, right? The dunder stir method for the child classes, we're demonstrating inheritance here because that is automatically pulled from everything that we defined in the parent class. All right, well, let's run this first, actually, just to see what we get as output. So we'll run this, and here we go. So we get our vehicle fleet. We see Chevrolet Corvette sports car. Now, again, this format is based off of this that we defined right here. So you can see we have the make, the model, and then in parentheses here, the vehicle type. So we have sports car here. We have the F string that's returned, basically the print method whenever we call start engine. And then we list the features on a sports car, and same thing for the truck and the electric car. So these all look correct based on what we defined, right? Our feature list is unique to each one and they appear to match. So far, so good. Let's move on now in our main program here and do a little bit more. So part of your assignment asks for some type checking and class information, and asks you to demonstrate using at least two of the following methods, and they are defined in your assignment. I think we have is instance, is subclass, dunder name, and dunder bases as the options you can choose from. So we'll go ahead and kind of walk through those here in the program so you can see what they do. So I'm going to make a different kind of section header in our program. So I'll do my standard three equals, and then we'll call this class relationships. Okay, so just formatting our output so we know where this part starts, and then we'll start printing some stuff. So the first thing I'm going to ask, is car one a sports car? Okay, so that's our question. And to check that, we can use the is instance on car one. And then this is all, it's going to accept two arguments. It's going to accept as a first argument the specific object, and then as a second parameter here, the specific class we're asking whether or not it belongs to. So I'm going to say just the sports car class here. Okay, then we'll ask another question. We'll say, is car one also a vehicle, right? Does it belong to the parent class? And we will use is instance again. This time we'll pass in car one, but instead of the sports car class, we're going to just pass in the vehicle class itself. All right, let's try some more. So we'll ask ourselves, is truck a subclass of vehicle? So now we're checking relationships between classes directly, not between an object and a class. And so to test this, we can use the is subclass method, and we'll pass in our two classes basically. So our truck class and our vehicle class. Then we will do, we'll go back to car one. So is car one the same object as car two? Do these point to the same place in memory, or are they different? And we can use the is keyword here. So we can just print car one is car two, and this will return a Boolean. If they are the same, it'll return true if they point to the same place in memory, and it'll return false if they're different objects. What else do we? Let's do class name. So we will print class name, and then we will use type of car one. And then we will do a dunder method here. So dot underscore underscore name. Okay, and we'll demonstrate what that displays when we run this. And then let's do some child-parent relationships. So we'll print sports car parents, and those will equal sports car. And then the method here is going to be dunder bases. Let me just double check. Looks like everything looks right. I'll just do another empty print at the end for spacing. Okay, so before I run this, let's talk through them again. So is instance that we used for the first two examples checks whether an object belongs to a class or any of its parents. So car one is both a sports car and a vehicle, and so both checks should return true here. Is subclass checks the relationship between two classes, again, not between an object and a class. So truck does inherit from vehicle, so it should return true here. This should return true for us as well. Again, is checks whether two variables refer to the exact same object in memory. Car one and car two are different objects, so this should return false, right? Each time when we declare them and define them up here, we are creating different objects. And then our last two, we have our dunder name and our dunder bases. Dunder name, and dunder, as a reminder, just means any of these kind of methods or keywords that have two underscores before and after them. Those are called dunder in Python. So the name gives the class name as a string. It's useful for printing. And then bases returns a tuple of any and all parent classes. So for sports car, there's only one parent in this example, which is vehicle. And so it should return a tuple just containing vehicle. Let's go ahead and run this now, and let's look at that output and make sure we confirm what we believe it should print here. So I'll run it again. And let me try to make the terminal output bigger. Bear with me, I'll try to make it a little bigger. Okay, that looks good enough. Let me clear, I'll run it from the top again. Okay, so the first part of vehicle fleet is unchanged. Let's start down here at class relationship. So is car one a sports car? That returned true as we suspected. Is car one also a vehicle? Yes, it is. Is truck a subclass of vehicle? That returned true. I forgot a question mark. I'll just add that there. Is car one the same object as car two? That returned false, so it is not. And then we have our name and base. So the class name for car one, which is what we passed in, is sports car. So that's pulling out the name of the class. And then sports car's parent class, and you can see it's a tuple indicated by the parentheses, and it's returning basically this Python syntax for a class called vehicle, which is the parent class there. All right, so all of that looks the way that we expected it to. Let's go ahead and continue on so that we can employ our try, except, else, and finally, which is another one of the requirements for your assignment. And we want to use this to handle our custom exceptions, right? So we're going to try to basically call a feature that doesn't exist on one of these individual car objects to demonstrate how we can use our custom exception here. So I'm going to do another section header. This time it's going to be called feature test. And then we'll start with our try. We'll start with our try here. So what are we going to try? Let's try to print car1.use feature. And then I got to remind myself, car1 is a sports car. So its features for a sports car are sport mode and launch control. So let's try one that we think will work for first. So I'm going to use feature, and then I'm going to call sport mode. This one should work, right? Because car one is a sports car. We have given it access to this feature. But next, I'm going to try one that it doesn't have. So same thing. I'll print car one, use feature, and let's use a tow feature, which doesn't exist on the sports car, but it does exist on our truck. Okay, so that's it. Let's move on, and we will do an accept unsupported feature error as error. And then let's do some printing here. So we'll print error is error. And then part of your assignment also asks you to print the error arguments. So we'll do that here too. We'll print exception args and error dot args. So the args or the arguments exists on this error object here. Okay, let's move on. So we have try and accept so far. Let's do an else block. And so if the try works, we can do print all features used successfully, something like that. And then finally, what do we want done regardless of what happens above? We can just print feature test complete here, right? So the finally, again, will always run at the end, kind of regardless of which branch we take and try except here. All right, and then after all of this, we'll just do a base print, and if I cover everything. Oh, let's print the vehicle count too that we've been tracking as we're creating these vehicles. So we can also do, just to finish it off, print total vehicles created, and then we will call the parent class its vehicle count class variable here. Okay. Again, just as a reminder for how this logic works with this try, except, else, finally, the try block calls use feature twice. The first one we expect to work. The second one we expect to fail because the sports car does not have the tow method. This will raise an unsupported feature error as an exception. And the reason it will do that is if we go to our use feature right here that we define in the parent class, we are telling it to raise this specific error, right? So we defined it up above in the parent class, which is inherited by all of the child classes. So this is where we made the decision to use this custom error. Now we're just catching it, right? With our accept, we are catching that error because we know it's going to be thrown in this use case. Okay, then we go on to our else block here. So the else block only runs if the try block finishes without any errors, any exceptions. And then our finally block runs no matter what. Whether or not there's an exception, finally will always run. All right, and then at the end, again, we are just printing the total vehicles created here. And that should be it. So let's go ahead and run this one last time and just look at this last section here. Okay. So again, everything above in class relationships is the same. Let's just look at feature test. So we have Chevrolet Corvette is using sport mode, and that is the print statement that we defined when we use a feature that it has. Then we try to use tow, right? And we have this custom error that we defined. Chevrolet Corvette does not support tow. We have our exception arguments, and our arguments was the specific string that was printed above. And then we have feature test complete, which is the finally block. And then we have total vehicles created 3, which is correct because, again, we just created those car 1, 2, and 3 in this program here. All right, so that should cover all of the core concepts that you will need to adapt this program, right, this demonstration to your specific assignment, which again is all about using classes and child classes and overridden methods and inheritance, right, to demonstrate what inheritance is in object-oriented programming and how it works. As you try to apply this to your assignment, you should ask yourself some questions here, right? So you can ask yourself when you're looking at your specific assignment, what's the parent class in this assignment? And then what does every object share from that parent class? Then I would ask myself, what are the child classes? What makes each child class different in your assignment? And specifically, what does each child class override and what does it inherit unchanged? That will help you in figuring out what you need to explicitly define in your child classes. You can also ask yourself, when should my custom exception be raised and what message should be displayed? I would ask myself which type checks make sense to demonstrate in your output. Again, you have an option to pick 2 out of a list here. I kind of demonstrated all of them for you. You don't need to do all of them in your assignment. So just ask yourself, based on the program you're designing, which one of these might make sense to display, and you can go with those. And then finally, the important one, where in the program is it natural to use try, except, else, and finally, kind of in this same structured format here. So if you can answer those questions first before you even start programming, then you're ready to design your own original program. Do not copy this example and use it in your assignment. Use this as a reference for the structure, right? Use this as a guide for how to do individual things, like how to define a parent class, how to define a child class, and use the constructor and then calling the parent class's constructor. Use it as a guide, but write it yourself kind of from scratch so it fits the assignment scenario in your own words. All right. So hopefully this gives you some more clarity or a better understanding of what's happening kind of behind the scenes here when we're using object-oriented programming in Python. As always, I wish you luck on your assignment, and I look forward to reviewing your original pieces of code. Thank you.